Hello and welcome back to the class of 5G. We were talking about trying to get the best of both worlds. Well, let's start with getting some fundamental acknowledgements. First, 5G has a different set of consumers. The earlier generations were just users themselves, along with their cell phones. In case of 5G though, the customer can be a person with a smartphone, an autonomous taxi, or autonomous home appliances as well. They are going to be connected to the internet. IoT has never said that it strictly needs to connect to cellular networks. And as far as internet is concerned, the second acknowledgement is that it's a major entity. Phones, computers, dongles, LAN cables, fiber optics, Wi-Fi routers, Bluetooths, there are just so many ways to access and spread the internet where you don't necessarily have to stick to one network policy. You cannot think of whole world covered with nothing but cellular towers. That's simply not how internet works. Of course, service providers want to earn as much money as they can, so they will portray that their network will handle everything. At least for now, the vision to monopolize internet through single technology is not just irrational, it is also irresponsible. 5G doesn't need to take over the internet. 5G needs to expand itself by coexisting with internet in a constructive way. One of those constructive ways is SDN or software defined networking. Before we dive deep into it, let's have a fun little game. The game is called Name the Devices. You will get a picture of a popular networking device. You will have to identify what type of device it is. You will get 10 seconds to guess, and don't worry about points, prize, winning or losing. It's just about doing a fun little exercise while learning. With that out of the way, let's get started. Here is your first device. What is this? It's a Wi-Fi router. Here is your second device. What is it? It might be a bit trickier than before, but I know you can do this. Correct, it's a switch. Now what is this? Bingo, it's a firewall. Next up, what is this? Oh, that's a cheat code right there. You read it right. It's a load balancer. Finally, something everyone is familiar with. What are these? And you're right, they are servers. Here are all 5 devices. Don't worry if you got one, some or all of them wrong, because after all, it was all about learning. These pictures are pretty bulky to move around, so let's swap them with icons. There we go. Now let's place them in the right order and connect them. It seems like the server is connected to the firewall, which then connects to the load balancer, which leads to switch, and finally to router. This is a full-fledged network. Of course, at any point of time, we can have more than one of each elements to make more complex networks, but let's take the simpler one for learning purposes. To understand its working, let's take a bunch of data packets with different security policies. If the server wants to send these packets to the routers, first of all, they have to go through firewall, where the firewall will determine that 2 of the packets are good to go, while 1 might cause security threats. Then the load balancer distributes them evenly to a couple of switches, which then route them to the intended router. All of these network elements and the links between them is called the network plane. On the other hand, their configurations like port number, protocols, firewall rules, routing algorithm, etc. are considered as the control plane of the network. Till now, these two have been tightly coupled. They are handled together and they are visualized together as well. But if we separate both of these planes apart, we can get a new topology where the elements can now be centrally controlled through servers. To do so, we need to take 2 steps. Firstly, replace some of the hardware with software like firewalls and load balancers, and define them within the servers. And secondly, merge the rest of the elements to the servers by handing over their configuration rights or by giving the means to access their configurations. Then all we need is just one console to control the whole network. This concept is called SDN, or Software Defined Networking. By definition, it is a network architecture with separated network and control plane by making the network centrally programmable and manageable using software applications to manage consistencies and meet cutting-edge requirements of low latency bandwidth applications. It is widely being used for cloud computing, but it has huge potential to extend for 5G and allow 5G to seamlessly integrate with other forms of networks. As we had mentioned earlier, 5G has many solutions possible, and not all of them are applicable everywhere. Having overload of high-frequency antennas in a forest would be like wearing a raincoat on a beach during summer. It makes no sense. But if we restrict such solutions to limited industrial premises, it has massive potential to bring large-scale automation for industrial IoT. We can't have a server for each and every tower out there, so it is important to extend something like SDN for such solutions. This can enormously reduce the time of deploying the network, and it also brings infrastructural agility. It provides finer control with better speed. Separating control plane from network plane allows control plane to be much more secure, while network plane to be much more scalable, which fits their natures perfectly. And since the solution won't be blindly applied to unnecessary places, it ensures long-term safety of humans and other life forms. In the next lecture, we will take a look at what is the reasonable current state of 5G. Till then, happy learning and have a fantastic day.